Hello and welcome. This is section 11.6. We are simplifying radicals today, and this is the first video. In this video, we are simply going to learn some terminology, and then after that, practice our hand at simplifying radicals based on 3 criteria. So let's get started. Here we go. Here are the 3 criteria, as well as a couple of the terms. The simplest form of a radical expression. First of all, we need to understand what radical expression is. So let's understand that. Radical expression is an expression that contains a radical sign. And if you're thinking, what the heck is a radical sign? Well, a radical sign is this awesome baby, that square root sign. That is a radical sign. So the simplest form of a radical expression, square root expression, there is no perfect square factors besides 1 underneath that square root sign. We don't want to see a 4 in there, 4 times 12 or anything like that. We can take that 4 out. We can take care of that situation. We can even take care of that 12. You'll find out soon. The radicals also have no fractions. So if we look at our example right here, we have the square root of 256 divided by 4. There is a fraction underneath that radical sign. We don't want that. That is not good. That's not a good situation. So the last one as well, there are no square roots in any denominator. We'll see that eventually in section 11.8. So another term that we need to pay attention to is this. A radicand. That is the expression underneath the radical sign. So we have the situation square root of 256 divided by 4. And if we look at that, the radicand is the 256 divided by 4. It's the numbers that are underneath that square root sign. The radical expression is the square root of 256 divided by 4. Okay, it's that whole thing. So that's how we can understand that. Let's actually do a little math. Let's try our hand at simplifying. If I look at this 256 divided by 4, I know I can do a little bit of math there. 256 divided by 4, if I were to do that math, I end up getting the square root of 64. Square root of 64, if I were to do that math, we just get simply 8. And I know now you're thinking, well, Ms. Beardsley, in the last few chapters, we've been paying attention to square roots, and when we take the square root of something, we get a positive and a negative answer. And you're right. We do get a positive and negative answer. But as of right now, I want you to just solely focus on the positive. And I say that just simply because what if we had the situation where we had the square root of 16 plus the square root of 25 all over the square root of 4. If I had the positives and negatives for all of those numbers, I essentially am looking at the positive and negative 4 plus positive and negative 5 over positive and negative 2. If I look at this, I quite literally could have 8 answers. And maybe only one of them's right. Who knows? Regardless, I'm not going to make you do all that work. That's way too much for our brains to handle. So instead, what I'd like you to do is only focus on the positive. Instead, we would say a positive 4 plus a positive 5 divided by a positive 2 is equal to 9 over 2. Much easier to think about one answer for that one expression. So think about that. Keep that in mind as we do this. Let's try our hand at a few expressions simplified. We have the square root of 40 plus 9. Think of a square root as a gigantic parentheses. And when we think of parentheses, we need to do the operation inside of that parentheses if we can. The square root of 40 plus 9 is essentially the square root of 49, and out comes my favorite number, 7. Kind of cool. As well, you're going to see expressions like this, the square root of 3 minus x squared. And if I look at this squared, regardless of what is inside of that parentheses, that squared and that square root cancel each other out. So our final answer for this is 3 minus x. Our last problem is a little bit more intense. We have the square root of 5 squared plus 12 squared. Do that math. Exponents always come before parentheses, or well, it goes parentheses and exponents, so we need to do essentially our gigantic grouping symbol, which means we need to do the exponents before we do the adding. We have 25 plus 12 squared, which is, I should actually write 144. So we have the square root of 25 plus 144, which is also equal to the square root of 169, which equals 13. Final answer. Regardless, I hope all of this helps. Please work yourself through the homework or work yourself through the next video so you can do the homework. And if you have any questions, as always, please ask. Talk to you later. Bye.